For those of you joining us on the video, earlier we talked a little bit more about dimensions, and we talked about Klein bottles and some other objects that are theoretically four-dimensional objects. I will go through and post a few more things on that on the website, so if you want to check that out, you can. Let me post the link. Is somebody checking to see if they can actually see it live? Because like I said, some of the freshmen had issues seeing it live the other day. Okay. I'll have to figure out why it says that, because I changed the settings. Maybe it's because it's on the school network. It blocks live streams. Interesting. Because I took it off of I made sure it was public, and I made sure that it was on. I didn't click the kids this time, but I did turn off chat. That's the only thing that should be off. So I don't know. I'll have to look into that. All right, anyways. So with vector addition, the thing that makes it different than normal addition is we do have to account for direction. Okay? Everybody good? So we've done this before. I just want to review it, make sure everybody's on the same page, make sure nobody's forgotten it completely. So we are going to start with a somewhat complicated problem, or at least it'll look complicated to begin with, so that I can point out some of the useful things we know about vector addition. Okay? Sorry, I'm off a little bit here. This should be 10, that can be 10, this should be 5, and 5. Okay? So we have this nice square here. Okay? I want to find the displacement, which is the distance from where we started to where we ended. Okay? So what I want to find, let me draw this in purple, is this line from here to here. Okay? So I need to find the length. We can also find the direction of that. Now, if we were to try and add this and assume that we couldn't take things out of order, this problem would become a lot harder, right? We would have to add, I guess we can say that this is north, this is east, south, west. Okay? Good? So, we would then have to use Pythagorean theorem to add these two. And then we would get a vector that would go this way. Then we'd have to use maybe like law of cosines to add it to this one. And it would be a huge mess, right? Luckily, order does not matter. Okay? So you do not have to worry about order at all. That means we can pick the ones that are easiest to add together. Okay? Obviously, ones that are going upward are not going to be hard to add together. And then ones that are going downward, we'll just subtract from them, right? So those are going to be easy ones to add together. Same with the left and right. Okay? So north and south we can add easily, east and west we can add easily. So what we're going to do, especially on a problem like this where you have a lot of vectors, I highly recommend making a list of, or two different lists, or two different sums, I guess, so that you can go back and make sure that you haven't forgotten it. Make sense? Okay. So here's our north and south sum. And here's our east and west. There's two different ways you can go through this. You can pick whichever one you like the best. Some people like to go like across this way. So they do like 20 plus 15 plus 5 minus 10 minus 20. And then do the same thing up and down. I prefer to go in order just so that I can work on both sums at the same time. Okay? Let's call north positive and east positive. Sound good? All right, so if we call north and east positive, our first 20 meters is going north, so it's going to be positive. We've got 20 meters here. Our next vector is 20 meters east, so that's positive. And then our next vector is 20 meters south, right? So that's going to be negative. Our next one is 15 meters west. That's once again negative. Then we have 15 meters north, so that's going to be positive. All right, we'll finish this up tomorrow. Have a good day, guys. Do you guys remember this? Yeah. Vaguely, at least? Okay. Have a good day.